Okay, we'll get started. First, I want to say thank you for BSidesCharm for selecting me and Dixon's speech about modernizing your context clues for CyberOps data through visualization and vectorization. AI models know what they know, and the probability and likelihood of an AI answering your questions is all based on what that AI model was trained on. Being able to have that leverage of vectorizing your data can enhance and give you a better knowledge base on what you're doing with vector databases and how you're putting your data inside and vectorizing it. But before we go any further, I'll hand it off to Dixon so he can introduce himself.
Hi, everybody. My name is Dixon Kwong. I've been in cybersecurity for over 15 years. My experience spans from working for the United States government, financial institutions, and tech startups. So my quote I picked, actually you see over there on the panel, is something from Mark Carney, who's the Prime Minister of Canada. Essentially, it's hope is not a plan, and nostalgia is not a strategy. And I think that fits what's currently going on in the AI environment entering cybersecurity. And what do I mean by that? Is that right now we hope that our current infrastructures and our resources can fend off what's coming or is already happening in the AI and cyber. We assume that our current defenses are enough. But the truth is, the reality is very challenging and daunting.
Hi, everybody. My name is Kevin Figueroa. I've been a cybersecurity practitioner for the last 3 decades. My first DEF CON was DEF CON 7. My first time I spoke was at DEF CON 16. I have an assortment of cybersecurity skill sets ranging from reverse engineering at Booz Allen Hamilton to threat modeling and pen testing at the IRS. And of course, much, much more, but there's so much that we have to go throughout the speech that I would rather not speak about myself and speak about what's going on. But one of the things, my favorite quote, and one of the things that always stood lasting was a former president said, "I don't give anybody hell, I just tell them the truth and they think it's hell." And I think it's really synonymous when it comes to pen testing, because God knows how many times you have to go and tell executives and they're like, oh, you know. But yeah, that's my favorite quote. With the AI craze going on and companies moving rapidly for adoptability in all sectors, whether you're in marketing, financing, cybersecurity, the pace for really being able to adopt and move quickly is starting to rise exponentially. And due to the fact that AI is now being able to discover these vulnerabilities, that rapid pace is hugely, hugely of urgency. One security researcher by the name of Nicholas Carlini, with the help of Opus 4.6, he discovered a vulnerability inside the Linux kernel that was 23 years old. And the fact that that predates GitHub blew my mind. So really, that pace of being able to rapidly react or better help your organization is moving fast. And again, vector databases is a solution that's going to help you. 3 major takeaways that we want you to absorb from this is, number 1, vector database technology rivals traditional databases. Second thing is the proof of value, the speed, the built-in similarity searches can enhance cybersecurity operations. And lastly, vector databases can elevate the organization at a completely different level just based on the sheer speed. And if you're able to use it from a local LLM perspective, the pattern matching, the visualization, the graphics, it's so much better than traditional 2-dimensional databases.
And as Kevin mentioned, about vector databases in themselves, the biggest benefit is that it benefits both a red team and a blue team. You rarely come into a situation at times where data from an offensive team and a defensive team is useful. But actually, in combination, it produces an incredible view, and we will be showing you guys that later on and during the demonstration. So with all the data, as we all are aware of, there's so much data, as you guys can see up there, whether it's from your firewalls, your network devices, your EDRs, so on and so on and so on, your WAFs, all that stuff. Everyone's dealing with it. We all put it into a SIM. We think it lives in a happy world, and then we need to search upon it, right? And especially when you're dealing with terabytes of logs, it becomes a bottleneck. It becomes a problem, right? If you don't have a sound solution, which a lot of organizations, truthfully, they don't have that solution. What here is that seeing that all the different types, what we're going to show you is that vectorizing your data not only natively integrates with AI, so that's already one thing that solves a problem there, but most importantly is that the speed in which Kevin will talk about in a second.
Throughout this whole speech, I am going to harp on speed so much that you're going to get tired of hearing me talk about speed. But cybersecurity threats is a battle that must be fought on all fronts. So if you're a red teamer, if you're a blue teamer, if you do bug bounties, by you gathering that information and being able to react faster, it's going to help you and your organization in so many different ways. But again, for me, that I'm always going to speak about red teaming because I'm a pen tester. So having multi-contributors to a pen testing engagement, being able to funnel all that information to give the appropriate information to the organization to better protect themselves is vital. And doing that at a rapid pace is key. The novelty behind this research about vector databases and modernizing your CyberOps data all stemmed from this one thing that me and my brother did. My brother's also in cyber, and we had the liberty to go ahead and pen test all of Puerto Rico. We're Puerto Ricans, and my brother had connections, and they wanted us to do it. What we found was when we started retrieving all this data, we could not put this in a two-dimensional database and be able to rapidly query this stuff. It was there, but it's taking a minute, it's taking 2 minutes, it's a lot of data. Once we started looking at it from a vectorization perspective, and these things were coming back in milliseconds, it was baffling to me, like how quick we're able to retrieve, how much we're able to use the similarity search engines with built-in Qdrant, which helped pattern matching, pattern recognition. That's something that if you did it manually, it's going to take time to find those different patterns. With Qdrant, instant, and it does it for you. And by the way, without any local LLMs or third-party AI systems. And one of the most important things about it all was when we were doing that pen test, being able to find that information so quickly, our reaction time to intelligence based on what we're going to target started narrowing down. Where before, when we were doing it manually in the beginning, it would take maybe like a week or so, maybe 2 weeks. With this, we were doing it within hours. And that is another thing where it blew my mind that, wow, this is really, really useful. I started this project about 4 years ago. And what drew me to this was, why is no one speaking about vector databases inside cybersecurity? And that's where this whole research came about. Of course, for me, I am always going to pick Qdrant. I believe in Qdrant. I'm a huge, huge advocate of Qdrant. So as I embarked on it, number one, it's open source. So the fact that you don't even have to pay for this stuff and you could use this free, that's how I started using this for my bug bounties. The built-in similarity searches, the hybrid searches, the filtering, so much faster. And later on in the slides, you'll see the differences of using regular syntax than regular natural language. And that's another key thing that enhances your vector searches and queries.
So when Kevin approached me, I wanted to expand beyond just Qdrant because I know he's a huge fan of it. And so as we all know, and some of you probably are using other vector databases, right? So we picked a subset, right? We picked out 5. Particularly, we started with Qdrant, but we also tested with ChromaDB, we tested with Pinecone, we tested with Milvus, and we tested with Weaviate. And these are used in very large organizations, as you guys may or may not be using. The first 2 that we're going to talk about today, due to time constraints, is just Pinecone and ChromaDB. So if no one has ever played with vector databases, what would you try is ChromaDB. It's a very lightweight, very easy to use. You put up a Docker image, and you can start running literally in minutes. And that's essentially what I would ask everyone if you're trying out any tools. Try it on Chroma.
No, try it on Qdrant.
There's always catches, right? Obviously, there's always pros, there's always cons. The catches of ChromaDB is that it can't not natively actually doesn't have any HA capabilities for high availability. It can't cluster natively without some additional help. And also, it has some constraints on vector size limits. The opposition we chose as well was Pinecone. Pinecone is used in a very big commercial space. There's very large organizations that use it, and it's in the cloud. So as it being in the cloud, of course, there's naturally HA abilities and clustering, and the support for the size of the vector databases is much, much larger.
So standard traditional databases are optimized for exact query searches, sort of like where age equals 30 or where username equals Bob. And that's good, but it's not where it needs to be, especially with the AI-driven systems nowadays. So calculating similarities between vectors requires high mathematical computation, which traditional databases may not be able to do. So designed specifically for proximity nearest neighbor searches and being able to put high dimensional embeddings behind that will allow you and give you the power to use a local or a third-party AI system.
And with that said, excuse me, with vector databases, whether again it's red team or blue team data, the power in vector databases over traditional is quite honestly the ability to do semantic searches. You can also tag the data inside vector databases with metadata as well. So imagine a situation that you know the source, you know the information in the service, and you can tag that data. Now your search replies, your search queries, everything will be affirmative, that you'll know and trust if you've tagged it correctly. That is something, again, a huge benefit of vector.
And to couple up with what Dixon just said, due to the fact that the attack surface is now being more broad and adversaries are now starting to use these AI and agentic and all these other pieces to start breaking into systems, finding bugs, your reaction time to this has to be equally as fast. So one thing that I really saw, I forgot the gentleman's name, but he was like, you know how packets have that time to live, TTO? Well, now the new thing is gonna be time to exploit, TTE. And being able to identify that real quick before an adversary winds up compromising your system is key.
And as Kevin's mentioned is his mantra about vector databases and speed, speed is power. Particularly when you think about whether you're red team or blue teaming. If you're on the red team and you're testing a target site, the faster you're into the network, the deeper you can go in. Now you got horizontal. Now you can go vertical, right? You could spread out, set up your positioning all across the network now. It's harder to get out. It's hard to get rid of you, right? Because you're in because of speed. Now on the blue side, where's the benefit in this? The fact is, again, with speed comes the ability to be able to detect the alerts. Your systems will alert you if you set up correctly, and you can act upon it. Obviously, combination of AI, you can probably most likely contain the attacker very quickly and be able to act fast.
And again, going back to the speed, I'm gonna harp on this. You're gonna get tired of me talking about speed. But being able to have that speed at your fingertips not only gives, for me again, red teaming, that power back in their hands, but it gives power back to the organization. So where your red team winds up thriving and also blue teaming is being able to search. really, really fast. And later on in the demo, you'll be able to see how quick this information is retrieved. And where traditional databases, you start querying, you're gonna have to use union statements and all these other things. Nowadays, with vector database, an executive could just say, hey, give me all hosts that have DNS running, or give me all the hosts that have port 80 open, and or anything that poses an interest to those executives, or red teamers or blue teamers. And again, that data analysis, being able to quickly correlate this information, being able to identify, query this stuff. But one of the biggest things too is once you start harboring that, who's in charge of threat modeling? And that's key for a threat model. Not only is it key for threat modeling to be able to do that, but visually seeing that. And that's one thing, another thing that we're gonna harp on here and we're gonna show in the demonstration, how you can visually see all these endpoints connect to one another. And that's really, really key with this. And that's what stuck out like a sore thumb for me with Qdrant, because if you're using these traditional databases or other vector databases, you're gonna have to need plugins, add-ons. I want this graph, I want this. With Qdrant, that's already built in. So worrying about supply chain attacks, you're not gonna have it. Also, again, as a red teamer, me finding that information, speed, again, being able to react to that. But not only that, having that actionable intelligence where I don't have to fumble around to look at this or look at that, and oh, what does this Nmap scan say, or what does this vulnerability scan say? No. Vectorizing all that data and writing really quick queries, and the query language for Qdrant, it's a JSON file. So there's no such thing as, oh, I gotta memorize what this union statement is or something. No. And again, we'll demonstrate that inside the demo, but having that ability to have queries based on JSON is huge, huge advantage.
So as Kevin's been talking about with visibility, right? We need to look at it as traditionally as we look at data, right? You're looking at a pen test report, you're looking at vulnerability report, right? It's traditional just list, right? I don't care how you import it, how you put it, doesn't matter how it is. The ability here is truthfully the ability about perspective. And what do I mean by that? Is the visibility that you're gonna see. Seeing nodes connect to each other because of the algorithm you've chosen, right? Can read and interpret your network, can read and interpret your vulnerabilities, and actually understand how to work KNN, which is your nearest neighbor, and then provide you a picture that you can actually visually see and that you can act upon. That is something that truthfully is what the game changer is of vector database.
Now again, remember I was telling you about where age equals 30. Here's one of the perfect examples. How many executives you know really know traditional syntax language? It's gonna be hard. And I'm not saying there aren't executives out there. That's not what I'm trying to say, but a vast majority don't. But I know there's one thing that they do know, how to speak English. And being able to query that data in regular, plain, old natural language is going to be super, super efficient for them. Again, that's where the power goes back into those execs and the organization.
All right.
No, come on.
So I gotta tell you guys a little story, just 2 seconds here, is about the pen testing tools we've already created for vectorization. So Kevin originally, again, on his pursuit, I would say, of trying to incorporate as many tools on Kali Linux, right? We've already incorporated 25 of them. Right now they're on GitHub. Literally, you can take the results, ingest it into whichever the 5 vector databases you choose. Right now, it's already out there, the code's there. So from there, literally, you can ingest it, play with it, start working with it, and seeing how it works in your current existing network. And I had to stop him and get him to focus on presentation, or there'd be probably 60 of them, but we'd have a broken presentation.
All right, fine. He wants to say that, now it's my turn. So when I started off with these tools, and I was like, listen, Dixon, we're gonna focus on Qdrant. He was like, no, let's do more. So I was like, all right, he's sort of like me with the tools, him with vector, all right, cool. And that's how we wind up putting all these different tools. What we're trying to do is take the whole Kali Linux, every single tool, and give you that ability to parse that data, make it with embeddings or without embeddings, and show you later on how to ingest it. And our scripts is up there on GitHub. And currently right now we have about 25, 23 tools. Hopefully by the end of the month we should have like 30. And as time goes on, literally we're focused on making sure that we take all the tools, red team and blue team. Now for any pen testers out there, how many times you run an Nmap scan and you see this? You're doing this against 100 nodes. I guarantee you're gonna get eye fatigue. And whoever says they don't get eye fatigue, please let me know what your secret is, because I don't wanna get eye fatigue either. But here comes Qdrant. And now Qdrant took this and made it look like this. That's where the power comes in. Being able to have a key value pair for each single piece of information that came back from the results, that's where you start building your knowledge base. That's where similarity engines come in. That's where being able to query this stuff. And then again, all the stuff that we're gonna show you, we haven't even touched on the AI part and using it locally. This is all built-in features inside Qdrant, and of course, the other vector databases. Now, here's another one. All right. Well, up here, right here, there's one that's scratched out. So I took sublister. This information is from a bug bounty. This is where I think another power comes, where down here was a similarity search. The similarity search that I used was UMAP, and it came up with this. But if I wanted to parse this information on subdomains or certain directories that I didn't want to use, I could literally point and click and scratch that out. Now, it doesn't remove it from the database, but it removes it from my initial search. And I thought that was super, super powerful. And not only that, I wanted to colorize it and make it like all the mail servers be blue and so on and so forth. But I just wanted to show you that being able to have all these different colors is really, really easier on the eyes in comparison to what I showed you with Nmap.
So for one of my examples for ChromaDB is simply put is I went ahead and actually talking about the power of natural language, right? You know, a lot of times, you know, we get these reports again that have a lot of data, right? Truthfully, 10,000 nodes, 20,000 nodes, 100,000 nodes, right? Depending on how large your organization is or your firm or, you know, which service you're in. So as a result, a simplistic view, again, with natural languages, I can just go ahead and type in the word Apache, right? It obviously, Apache has many products beyond, of course, its web server, but nevertheless, it's nice and simple. You don't have to overthink it. Gone are the days that you have to worry about port mappings and running a script to correlate things and all that stuff. And again, most of the engines do this to a degree, but imagine again, this has no attachment. And building it in Chroma, or you're using Qdrant like Heavenwood, or any of the other vector databases, you now have a system that doesn't require a SIM. You don't require to pay somebody X amount of dollars. You can literally query your data intelligently, and you can target it intelligently, which will give you actionable abilities. And so for here, again, as existed, there. So as you guys see, you know, you can go by ports and you know, SH, Windows links. You know, obviously it's whatever your heart desires, but again, you're asking for it for data. So on the flip side, nuclei. So for those of you who don't know what nuclei is, I would probably consider it a lightweight vulnerability scanner. And essentially, what here I used with Pinecone actually. So with Pinecone, I went ahead and worked with it, and essentially similar thing where you can type in headers, right? In this case, I used just damn vulnerable web application, but obviously it'd be whichever site you choose and target. But again, using headers. I know many of you that obviously are in the cybersecurity world, we've all done it. You know, you're importing, you have to ingest and read this giant PDF, this giant Excel file for your audits, for your compliance, your GRC. Again, imagine you can ingest this into a vector database of your choosing. It runs air-gapped. And now you can query data without relying on any third party. You're not paying licensing fees. You're not paying any of that. And you can get results that you need that you can action upon.
And by the way, it's free. Same thing. He did it with Pinecone. I did it with Qdrant. And here, I know it's kind of hard to see, but right here, here's where embeddings come into play. So where he's talked about that air gap system. Once you start having this type of information and it's all has a specific embedding that you choose, now you don't need that third-party AI system. Here it is, you have a local system. Of course, we've been experimenting a lot with different embeddings and different models. And boy, is that a challenge. Because God knows how much, like, I'll give you one example. We took one embedding, and it's all mini LM L6 V2 embedding. And I wound up using Quinn code for that. And then I tried Mistral. And then I wasn't getting the results that I needed right away. So we're still playing around with it, but one thing that we did get immensely was exactly what Dixon showed with the ports and Apaches and different words. Of course, words is one thing, but being able to do it in a sentence is another. And so sometimes it works, sometimes it doesn't. And that's where that repetitive model training. Currently, me and Dixon are working on a cybersecurity model out there that we're trying to put together because we went to Hugging Face. There's 8 of them. They don't work as efficient as we thought they would. But one of the other big, huge things is down here. So all of these are the same for using nuclei. And what I did was I asked Qdrant, not only do I want you to put this and in a tree graph, but make sure that the tree graph has the similarities to one another. And that's something where if you did that manually, that's going to take time. Again, that was done in milliseconds. Now my reaction time to start looking at this stuff is starting to pick up the pace, you know? So that helps and gives the power, again, back to the organization to help them defend themselves, pass it off to the blue team, make sure alerts are put, things like that. This is another example, and this one blew my mind. I'm literally working on Qdrant to figure out how it did this. And I know it's because it's using PCA algorithm in there, but I want to know why it did this. And I'll give you the example. So I did a bug bounty on a specific domain, and right here, that little spot was the root domain. When I clicked on that domain, it literally created this. Again, no LLM, no AI. And what struck me was all these different nodes on the outside, these were all their cloud providers. And as I start going in to start checking, there was a mail server, 365, so on and so forth. It understood that by itself. That is a lot of power. Because now I don't got to worry about all these clouds. I can look at this specific host or server or things like that. But it doing it by itself blew my mind. And that's where that power comes back to the user and the organization. Here's another instance. This one's another one that's really, really good. Keep your eye on that little point. Now, I use Firefox Buster. I ingested 46,000 endpoints. 46,000. Me querying 46,000 came back in 5 milliseconds, where traditional databases may take a minute, let alone that I got to worry about, oh, I got to find what's the joint statement with all these different databases. It did it for me, and it made that graph. So I was like, wow, why is this little one out here right away? That pattern recognition, I don't got to worry about it. It's doing it for me. So what I did was I clicked on that, made another query, and said, out of the 46,000, give me the top 2,000 that are similar to that little one right here, which was this graph. And then I said, out of that 2,000, give me 500 and then extract the top 100 out of there, which was this. Now, all of this was done in about 15 seconds. That brings power and speed right back to the people that need it the most, whether it's red team or blue team. Again, I don't want to go deep because I really, really want to get to the demos. The demos where it's at. But here are the 3 algorithms that are built in with Qdrant. And if you have small data sets that are 5K or lower, you would wind up using TSNE. I'm constantly using UMAP because sometimes, like I said, I use Fairvox Buster and I get 46,000 coming back. I may use DNS Recon and I only get maybe 1,000. So I always found that UMAP is a nice medium between low and high. Again, having that acceleration, being able to find things within milliseconds, and being able to reiterate through that brings that power back to you. And I can't stress enough on the speed. But one of the biggest things about it all, as me being a red teamer and being able to analyze this information quick, I can now forget about all these other pieces and really hone in on the target that I want to compromise. Now, take this from a threat modeling perspective. If you're a blue teamer and you're worrying about malware, or you're looking at alerts, you're looking at different attack vectors coming in, being able to cluster all this information and connect the dots, again, I'm not saying that you can't do this with traditional databases. I'm just saying it's faster and quicker when you do it with a vectorized database. So I took that same example. And what I did was I took the top 50, for me, in my opinion, top 50 web and API vulnerabilities. I created this whole little pattern. When I did my next bug bounty, I didn't even worry about the bug bounty. I just told the database, if you find anything that looks similar to what's this, please point that out to me. And again, I'm not using AI at all. This is just the database. Being able to graph that out like that, and now every time I go to a different engagement, using that set and just say, hey, find this, I could wind up saying, hey, I'm going to work for like 4 hours, when in reality, this took 2 minutes. That speed is unparalleled. Now, I know most of you's probably thinking, oh, this is like a RAG system. No, it can be used as a RAG system, but it's not. We wanted to make sure that you're able to query this, and that's why I'm focusing so much on the vector side, because not only can you use this while you're querying it directly to the vector database, but in our presentation, Dixon's going to show you how to connect it to a third party. I'm going to focus more on exactly how to do these queries, showing you the visualizations. But if after the speech you want to see how I connect it locally, it's literally on my laptop. Oh, and by the way, I totally forgot this in the beginning. I got a super high-powered machine. I got another machine that I brought with me. It's old, like maybe 7 years old, M1, 16 gigs of RAM. And it's still outperforming any of those traditional databases. And if you want, I'll bring my laptop, that old laptop down to show you that speed.
And exactly what Kevin's talking about with, we're talking about the RAG model here. The truth is, and what we want to demonstrate to you all is the power of vector is, again, 3 things. Is that the flexibility of a vector database comes in, essentially, you can run it standalone. Where, again, this is air gap, this is running at your home, this is running on his laptop that has 16 gigs of RAM. You can run on anything that you own, and you can query it directly. You don't need you don't need to pay any of the big guys, Anthropic, OpenAI, etc. You can just use it as a query system, whether it's for your home network or small business, or even some mid-size to a certain degree. But let's say you want to add that intelligence. You want to go ahead and add that local LLM, right? You like a model for interpretation that'd be to give you that intelligence, no problem. And you'll be able to pair it up with a local LLM. And again, your data is your data. It doesn't go out the wire. This is everything enclosed. And it's great for a lot of systems, as you guys could probably imagine. And what I'll be demonstrating today is I have a video of myself Essentially, again, using ChromaDB, I think it's one of the easiest ones to start with. And all I'm going to do is
Qdrant.
what I'm going to do is connect. I connect to OpenAI, right? And of course, this video was created a little bit while ago, so it just had chat 4. But I essentially am going to be using the ADA 002 and text embedded model, connecting to OpenAI, and again, just running just like you would do right now at home, any simple question, but it's going to use the intelligence of a third party. So
we're coming up very close to our demo time. But one thing that I wanted to say is, I know this sounds complex. Does that look complex to you? We try to make this as simple as possible. Dixon is going to show you the video. The video is 6 minutes. In 6 minutes, you're able to have this power right at your fingertips. But one of the things that we want to show you is down here. This is where your LLM resides. Of course, you have your documents or results, how to chunk them, embed them. Of course, I'm going to put Qdrant, but you can put any vector database right here. But this is the beauty of it. If you take this out, it still works. If you put it in, it enhances your ability to query this stuff a lot faster. With that being said, girls, I love you. My daughters are here, my sister's here. They've been so supportive of me. And I really appreciate it so much, girls. I love you. So many other people, but I thank my daughters.
And again, for myself, I thank obviously BSides for hosting us. Really appreciate giving us the opportunity here. We thank you all for coming in, and of course, some of our supporters. I see some of my people came in. I really appreciate them coming out and supporting us here on stage. And I think it's time for demo time.
Yes. So we have 2 different demos. One that we did with video, just in case the demo gods want to mess with us, and one that I'm going to do live. So I'm hoping everything works out with the live one. But with that being said, give us a second.
So again, we're going to go through really basic install. This is meant to be 0 to hero, and I literally mean that in all sincerity. What I mean by that is you're going to see pip installs. We're going to go literally, you're going to see all the libraries I install so that when you have confidence, when you go to that GitHub and you're like, well, these 2 guys on stage said it was so easy, I'm going to literally walk it through you right now. So what the goal will be here is to utilize ChromaDB. We're going to take Nmap results that, of course, you can run anywhere and get anywhere, right? And just to play with the results. So, Kevin, if you may, please. So, obviously, I'm just demonstrating. We got an XML right there. That is your output from your Nmap, right? Standardization, nothing new. I'm going to go ahead and create a virtual environment for Python, right? Because I don't want to mess up my Python environment. Nothing fancy there, right? So we're going to go ahead and activate the environment so that it is usable, right? So now with the virtual environment there, as we see, I'm just going to start with XML to dictionary. Now what is the purpose of that? That is part of one of our converters. So what we provide to you on the GitHub website is we provide you a converter to convert the tools to be able to actually be ingested. And then from ingestion, you go ahead and lead to the query. So it's 3 pieces. You guys, you see, I just went ahead and cat the file out. Nothing fancy there. Again, everything's on GitHub. You guys can review the source code. Right, so what I'm gonna do is go ahead and execute it, right? If my fat figuring there for a second there, right? I'm just gonna execute it. You guys see, it's very, very simple. All I'm doing is converting that XML to JSON, exactly what Kevin was talking about earlier, where vector databases prefer JSON for the most part. So, great, awesome. I have my converter script, I have the JSON, I have the original XML, right? So now we're gonna cat it out to show you again, nothing fancy, just turns into JSON. It's all good, right? So I'm gonna clear the screen. Now, as I mentioned earlier, we've done the conversion, okay, to JSON. I install a pip install ChromaDB. Very simple, right? You see it fly through, it goes through. And it takes a second. And there we go. So now I'm going to go ahead and download. I'm W-getting essentially the file that's a test connect. Now, why do I do that? Because as many of you probably tested code on GitHub or other places, it drives me nuts when I can't get the results of what the tester is, and it could be a configuration error. That test.connect simply gets a heartbeat and makes sure that the ChromaDB is listening. Once again there, go ahead and install the wheel for that piece. I'm installing now the nmap to to OpenAI, excuse me, the script, right? So go through. And what we're gonna do is go ahead and that's going to ingest into it. So again, after the test connect.py, I went ahead now and executing the nmap to ChromaDB. As you see there, I like my code to have documentation. It drives me nuts when people don't put documentation and don't have an easy to use interface. So I do pride myself on that. I just successfully imported 50 hosts into my ChromaDB into a collection called nmap test. Oh, I have a porter, I should be using that. Right, you see right there. So now simply again, now how do I go ahead and connect this to OpenAI? We go and do a pip install LangChain at OpenAI. We're gonna do this for 3 pieces of LangChain. Right, so we're gonna see here another pip install LangChain with the Chroma, right, for ChromaDB. And last but not least, we're gonna do classic. So LangChain classic. Let's go ahead and install that. Okay. So then now is the last piece. We've converted the data, right? We've converted the data. We've ingested it into ChromaDB. Now, how do I query it? How do I actually get results, right? The important stuff, right? All I'm doing up there, as you guys can see, is simply querying it after I wgetted it from LangChain. Bam. That was what Kevin was mentioning about RAG model, right? Now this, remember, my demo here is actually querying OpenAI and using ChatGPT 4. But as you'll see here from the data set, I literally query against my data. It returns all the results. Right here, it tells you all the different services. Obviously, again, that depends on your data. You know, if obviously you're pinging hosts that, or you're getting hosts that don't have data. But in any case, see here, I went again against that. We go against Redis, right? Which hosts are running Windows within the data set I imported. Goes ahead and tells me which exact hosts are running 2022. Which hosts are running Linux. Goes ahead and runs. And obviously, again, with even chat, right? FreeBSD, we know that's Unix and it's not Linux, but nevertheless, you know, that's a chat thing. But that's the catch about LLMs, right? You have to keep running them through. Are there any services running on non-standard ports, right? So again, with intelligence of an LLM, and depending on the model, you'll be able to look through and see if there's certain things maybe running on non-standard ports. It's supposed to run on 443, it's running on 9,000. You know, stuff like that. Also, the cool part about tying it to an LLM is some people didn't know what Rancher Service is, right? It helps out with K8s. And so you could just simply ask it, hey, what is Rancher Server? Because I don't know what it is. And obviously, it'll tell you all about what Rancher Service does and everything like that. And of course, it tells you down there on the bottom, the IPs. So literally, a few minutes of your time, you got running a local model in this case. It is going out for the AI portion for the LLM for OpenAI, but that's why Kevin's going to do a live demonstration of literally using Qdrant, air-gapped, running right on his laptop.
Hello. So I'm not going to go into installation here. People that use Docker, go into Docker, download Qdrant, super simple. Configuration, unless you're going to deploy this inside your environment and you need permissions, credentials, things like that, that's a whole different story, but we just wanted to get to the point. So here's a Docker instance that's running, and it's literally running on port 6333. And when you use your local browser, that's what it looks like. They have a nice, and this is all built in, by the way. Very, very minimal configurations. For this demonstration, I did 0 configurations, and literally that's the way it comes out. So they have a nice welcome screen that you can go through. Another function that I really, really love here is this built-in console. It's almost like a web terminal console that you can go ahead and query this information. And here is where I have a whole slew of queries against what I've been doing. And I know I'm going quick, but I will take this step by step. I just wanted to show you how the query interface is. But say I don't want to do it through here. Here's another way that you can start looking at your collections. The collections are all laid out. You can have it in So these collections right here are all without embeddings. The ones towards the end are with embeddings. Now I'm going to show you the difference between them. Here's one of the bug bounties that I did. And all I have is these three because I just ran AMAS. But now, if I wanted to see it with embeddings, you'll see at the bottom here, maybe you can't see it, but that bottom piece right here says embeddings. And then you literally can click on that little drop down. And for those key value pairs, which are only 3, the embeddings are listed there. And you can do queries against embeddings or queries on specific key value pairs. And I think that's huge advantage. All right, so now let's start seeing how this really works. I picked AMAS. I run this just to see how many, can everybody see that or no? Semi? All right, well, in this query that I did, which is just exact true, it shows me what's the total amount of points do I have inside that collection. And that can be useful later on where if you're doing something like Fairbox Buster for one bug bounty and I'll use it against another, sometimes you may not get all the same results, but you need to know how many endpoints you have in there. Here's a quick way to do that. If I wanted to go and start seeing, hey, how many MX records do I have all together? You could see how quick that came up. And this is not taped. I literally clicked instance. Now I want to visually start seeing this data. You can literally copy that query, go into your AMAS collection, go into visualize, and right here, you would literally stick that same query, run it, and now that similarity search, you see there's different points. And this is where value comes into play heavy, where, oh, these two are closer, so I'm gonna wind up looking at this because it classified them in a different way than looking at something like down here. Now, if I wanted to go ahead and say, I want to see what the relationship between these are and how they connect to one another, I would take the same query, go back, go to graph, copy that, hit run, and now it automatically did that. What I like about this so much is it went really fast. And being able to detect, if I start looking at these different points, if you notice that the information on your right-hand panel, right-hand panel starts changing. So say I come across one of these and I'm like, oh, this seems interesting. I could double click. It automatically did that by itself. That's something that when you start looking at pattern matching, that's what's gonna start elevating your game a lot faster. And being able to see that pattern from a red team perspective, you'll be able to start targeting things much quicker. Are we good on time? All right, let's get to some nitty-gritty good stuff. I did an SSL scan on a bug bounty, and I want to know whether they have TLS. I know people are going to say, oh, SSL, V2, V1. People don't use that. No, maybe not in this country, but in other countries they do. And I'm going to show it to you right now. So in this specific query, I have 105 different points. In those points, I want all the information that relates to IP, target, and the protocols being used. So I would first run it, and you could see there in each one of these, there's more information. But because I only asked for this specific information, it gave me that. Now imagine doing, again, something like that with regular syntax language. Your query will probably be super long. In here, it's 1, 2, 3 lines. Also, being able to identify this right away as quickly as possible is huge. Now I want to be able to graph that out and see how that looks graphically. Literally, it took, out of that 147, there's about probably 50 here. And you've seen it was instant on the connections, on the correlations, something like that. Again, doing that manually. Who knows how long it'll take. Sorry, you can zoom in on it. One of the other things that I really like about this is as I'm starting to go through this, and if anything comes and sticks out to you, you could literally click on it. It'll automatically change the graph and say, and if I wanted to, I can pull them apart to see which one's closer to one another. That's something, again, where if you needed to do something like that and you're using like Neo4j or any of these other different tools, you're going to need plugins, you're going to need time, you're going to need all this stuff. This is already built in Qdrant. Okay. I wanted to keep going until they kick me off stage. But please, I know we're running out of time. There's so much information. If you see me out there, please, you want to know more, grab me. Pull me aside. Let's get to the table. I'll open it up and go through it with you. And if you want, again, I have my super old laptop. I'll bring that down so you could be able to see it too on old systems. And I say that because I came up in a time where I didn't have a lot of money. And being able to use things that you have at your disposal instead of saying, oh, I need to save up and get this high-powered machine, for me, that's another reason why I chose Qdrant, because you can still use it on low minimum resources and still get the same value back. Once again, thank you, everybody, for coming. I really appreciate it. Thank you, girls. I love you. Thank you, Dixon. And thank you, BSidesCharm.
Thank you, everybody.